So the next thing is going to be units and temperatures. So imagine that I told you that I want you to go buy 200 meat at the store, or I said go and buy 400 water at the store. What's wrong about these two statements? If you analyze them critically, you will realize that these numbers, 400 water, really makes no sense because there's no unit. Is it 400 bottles of water or what is it? Makes no sense. 400 meat. What is the meaning of 400 meat? If you go to the store and you tell the person selling that you want 400 meat, it makes no sense because naked numbers have no meaning. Numbers only have meaning when you add units to them. And so this section concentrates on that. Okay. So dimensions have units. When we're talking about dimensions, we're talking about length, talking about volume, mass, density, temperature, right? These are dimensions. Okay. And so in the United States, the system that is being used is the imperial system, whereby mass is measured in pounds, volume is measured in gallons, distance is measured in miles, temperature in Fahrenheit. But in the metric system, which is the system that we use in science, units are different. Length is measured in meters, volume is measured in meter cube, right? Mass is measured in kilogram, and so temperature is measured in Kelvin, right? So, however, right, even though we use the metric system, we also recognize the fact that these other units are known as SI units. Okay. So the Kelvin, the SI unit for temperature is a Kelvin, right? But other units exist, like the Fahrenheit that we use in the United States, the Celsius that we use in Europe and other countries, right? And for mass, right, we have other units like the gram and the pound. They are known SI units. SI means Système International. That was a word that was it's a French word that was adopted. So the acronym SI is adopted by every country in the world of science. Okay. Now we have other dimensions, right? Like pressure, time, energy, amount of substance, energy, or electrical current. The SI unit are listed here. For pressure is the Pascal, time is the second, energy is the joule, amount of substance is the mole, current is the ampere. The symbols are listed there. We also have non-SI unit for both of these, for all of these dimensions. Now, this is a quick activity to see if you can identify the dimensions that are being talked of here. So when we use a kilogram, what dimension is that? If you go back to the table, the previous table here, if we go back to the previous table, you realize that the kilogram is a unit for mass, therefore the dimension we're talking about here is mass. Okay? So when I'm talking about 100 miles per hour, this is a multi-dimensional unit, right? The mile is a unit for distance or length, while the hour is a distance is a unit for time. So there are two dimensions here, length divided by time. Gram per mole, gram is the unit for mass, right? And the mole is the unit for the amount of substance. Gram per milliliter, gram is a unit for mass, milliliter is a unit for volume. So those are the dimensions involved here. Okay. So when we write 1 centimeter cube, that is a unit for volume. So imagine a cube, right? That measures 1 centimeter. Remember the volume of a cube is side times side times side. In other words, length times width times height, but the length, the width, and the height in a cube are all equal. That's why we say side times side times side. So if you have a cube that measures 1 centimeter, you multiply 1 centimeter times 1 centimeter times 1 centimeter, right? When you multiply the numbers, remember the units also multiply themselves. So centimeter multiply centimeter multiply centimeter, that's what gives centimeter cube. Okay. And so do not forget that 1 centimeter cube is equal to 1 milliliter, right? So if you don't want to write centimeter cube, you can just write 1 milliliter. Now let's look at temperature, right? In the United States, we use a Fahrenheit, but if we have to convert this to other units, right, we have some very prominent temperatures, right? Like 0 degrees Celsius, that's the freezing point of water, right? 100 degrees Celsius, the boiling point of water. Now, if you want to convert from Kelvin to Celsius or from Celsius to Kelvin, that is the formula you're going to use, okay? So if I want to take a temperature in Celsius and convert that to Kelvin, what I need to do is I just need to add 273 to my Celsius temperature to get my Kelvin temperature. Example, if I wanted to convert to negative 273 Kelvin, no, negative 273 Celsius, if I needed to convert that to Kelvin, what I need to do is that I just need to add 273 to it, and it gives me 0 Kelvin. And this temperature is very significant in science and is given a special name called the absolute zero. So it is a very, very cold temperature, right? And the significance of this temperature is that at that temperature, it is believed that molecular vibrations will stop. Okay, and so molecules in matter will stop moving. And there is a lot of controversy on whether this temperature can actually be reached because it is extremely cold. All right, that is that for this section. See you in the next section.